Hey guys, this is Azul Maksud. I am again with part 7 today. This one for real time interview crackers. Today's one for AWS related interview. Deeper understanding the key AWS services and features which I faced in my real time. All the projects I have accumulated total 20 questions here. Questionnaire 1, 2, 3, 4, 5, 6, 7, like that, 20 total. So let's see the explanation of this 20 questionnaire. It will be helpful for you guys in the real-time interview. You can get here DevOps Q&A. Still I have not done, but I will be doing. So let's see the questionnaire here. First of all, what are the types of virtualization in AWS? AWS supports two types of virtualization for EC2 instances, SVM and PV and SVM. Hardware virtual machine, para virtualization. SVM. This type of virtualization uses hardware assisted virtualization and provides better performance as it directly uses the host's hardware. So SVM, normally when we open the EC2, we can see the SVM, hardware virtualization machine. This is for hardware assisted virtualization and provides better performance. And PV, para virtualization. This is a software assisted virtualization where the guest operating system is aware of the hypervisor and runs with less overhead. It's used for older instances and provides lower performance compared to SVM. So this is interesting. PV actually for older instances. Okay, so now the new instances we see vastly SVM. When you open the instance type, then you can see the Ubuntu or anything else you can see there inside SVM. PV hardly not watching because this is the lower performance, so PV not used like that. But the question is how AWS supports how many types of virtualization, or what are the types of. So two types of virtualization, SVM and PV. Scenario use cases of for SVM for a high performance. See here, application like database or a web server with high traffic. SVM assistance would provide better performance and scalability. For PV instance could be used for legacy applications where the operating system might not be compatible with hardware assisted virtualization. So this is clear from here. See here, SVM for database and web tier, right? So which one is left? Application tier or logic tier or backend. So front end, backend, database, right? So the database and web tier. Web is the front end. So which one is left? The backend. So backend can be used with PV. So this is the normal solution. So keep in mind that front end and database for SVM and backend for PV. Easy thing in the interview, just explain like that. And one more thing, backend for PV. Why backend is not so much it's like legacy type, not legacy but legacy type, because backend works as an API. That means it's making connection with frontend and database. It means making the connection with the logics there. So it does not need too much speedy something. So yeah, for the speedy, for high performance, speedy means high performance, we use the something SVM for database and web tier. What is the difference between T2 micro and T3 micro instance types? T2 micro, part of T2 instance family. It offers a baseline CPU performance with the ability to burst when needed. Normally T2 T is the burst family. Burst means when needed, just bursting like that. So think easy, then it will be more easier to memorize like that. Okay, so scenario use cases for T2 micro, suitable for lightweight applications like a small web server or testing environments. Basically, in the real case, testing environment I'm using, not the web server actually, but a small web server sometimes. But I don't think the web server, that's better. Like a testing environment, like, yeah, that's better. When where occasional bursts are needed. Use cases for T3 micro, ideal for production. Yeah, see here now the production has come, that means web. Ideal for production workloads that require highly better performance than T2 micro, such as small web application, dev test environment, or small database. So normally T3 means, that means highly actually burstful, better than T2, and is for production related. T2 micro, this is also free tier for the non-prod, that means testing or QA, like that, easy thing. What are the different types of EBS volume types and their use cases? EBS volume, first of all, is general purpose SSD, provision IOPS SSD. So two kinds of SSD, one for general GP, we say GP, see here GP2 or GP3. Actually right now we are using GP3 basically. In the real-time project we don't use the GP2. So general purpose SSD, provision IOPS SSD, magnetic standard, cold HDD, throughput optimized HDD. So HDD is also two types, cold and throughput optimized. That means cold HDD SC1, ST1, throughput optimized ST1, and general purpose also 2, and SSD is 2. See here, one GP2 and one IO1. So GP3 actually offers a balance between price and performance for most applications, and this one IO1 SSD, that means IOPS, for workloads that require high performance with low latency, like large database. So normally keep life easier for database, we use provision IOPS SSD. So provision IOPS SSD for database, and other things without the database we are using SSD normally. So SSD has also the pricing and performance, it has the balance. So vastly SSD is used. Magnetic standard, older generation storage offering lower performance, ideal for archival and infrequent access data. So magnetic actually see here for older generation, for archival. Actually magnetic not used vastly, especially for the new project. This is for the big organization. Magnetic standard is used. For the new project or something smaller organization does not use like that. And then cold HDD SC1, best for large data set with low access frequency, such as logs and backups. Cold HDD. So for large data set, so here is the cold, that means something should be stored, which one is not used right now. So that one should be in the cold HDD for logs and backups. So actually I am using for backups, okay, for cold HDD. Throughput optimized HDD ST1, ideal for frequently accessed throughput intensive workloads like big data and data warehousing. So data warehousing actually HDD and big data. So I'm using HDD for something analytics in the data warehousing. So this is for why frequently access, it has a frequently access and throughput in intensive workloads, so we can get the frequently accessed. So these kinds of 5 EBS volumes, you have to know the use cases. When the price, this word is coming, price, lower price but better performance, just GP3 actually used. I think 90%, more than 90% EBS is used the GP3. Okay, then scenario, use cases for general purpose SSD, perfect for a small EC2 instance running a small web application where performance is balanced between cost and speed. And for IOPS SSD, um, use this for an EC2 instance running a high performance. So this is the for a small performance, right? For high performance for IOPS SSD. So such as MySQL, PostgreSQL, which requires consistent and low latency IOPS input output performance. So IOPS SSD, this is for actually used for databases. Okay, just keep in mind, IOPS SSD for databases, and GP is used for web tier, that means web application, that means front end, and also for back end. So IOPS SSD for database, keep in mind. So this it will be easier, always the three tier, right? Front end, back end, database tier. So if database tier is used for IOPS SSD, that means front end and back end for normal SSD, and that means general purpose. The use case of magnetic for low cost storage of infrequently accessed data such as logs and backups. Okay, actually backups are used too much for magnetic. Use case for cold HDD, ideal for storing large amount of data that don't need to be accessed often, such as old archives of infrequently accessed files. That means don't need to be accessed often. So all something is going to the cold. And use case for throughput optimized HDD, best used for big data application or log storage, where large amounts of throughputs are needed but latency is less critical. I'm saying something when the question is coming for analytics, data analytics, that then it's coming the answer for throughput optimized HDD, and for archival needed it's uses for cold HDD. For archives, old archives for cold HDD, and for data analytics, large amount of data, that is for optimized HDD. Why do we associate an IAM role with an EC2 instance during its creation? An IAM, Identity Access Management role, is associated with an EC2 instance to allow the instance to perform actions on AWS resources on behalf of the user. For example, if EC2 instance needs to upload files to an S3 bucket, see here, the IAM role grants it the necessary permissions. I showed this one here. Where is my just immediate, I think this one, file uploader. You can see my this video here. I showed how the IAM role is used there. So actually EC2 instance cannot do anything else without having the assistance from IAM role. So EC2 instance, its hands is like IAM role, Identity Access Management role. Okay, so scenario, use case, if your EC2 instance is running a backup script that needs to upload files to an S3 bucket, associating an IAM role with the necessary S3 permissions, that means put object. So that video is really very much helpful for you guys if you want. That eliminates the need to configure individual AWS credential on the instance, improving security and manageability. What are the use case of tags in AWS? Tags are metadata attached to AWS resources to help organize and manage them. Tags can help with resource identification, cost allocation, and automation. Normally identification for what kinds of EC2 instance or like that. This is metadata, that's flag like that. Is for identification. When identification done, then your account manager can see how much cost would be like that. Also, it is helpful for the DevOps engineers also, how I can do the automation. Scenario, use case for EC2 instance tags. Suppose you have multiple EC2 instances running in a developed environment and you want to track resource uses. You can tag instances with information like environment, development, application, that means key value. Environment, this is the key value. Development, environment QA, environment production, like that. then application key, web server, then owner, dev team. So like that. This helps with cost allocation, then identifying underutilized resources and reporting. What is the advantage of attaching an IAM role to an EC2 instance, and instead of using access keys for users? Attaching an IAM role to an EC2 instance removes the needs to configure and manage access keys. So when the IAM role is there, then no need the access keys, which can be compromised or misused. Access keys sometimes, compromised and misused. It also avoids the complexities of rotating credentials for individual users and enhances security by ensuring that permissions are attached directly to the instance. Scenario is like that. Use case for a scenario where an EC2 instance needs to access multiple AWS resources such as S3 bucket and DynamoDB. Attaching an IAM role provides seamless access without embedding sensitive access keys within the instance, which could lead to accidental exposure. So this is very much important why the IAM role is used. Just think that IAM role is used to avoid the sensitive data exposure. Sensitive data can be exposed through which one? The access keys. Access key is giving the long key like that, hashed keys, access key, secret access key like that. So this is exposed either way. At least the user can see also, or anyone is beside you watching maybe. So to save that, this is used like that. So what are the security options available for controlling access to EC2 instances and other AWS resources? Security groups, knuckles, IAM roles and policies, tags. So when security option is coming, see here, option is important. Security options, that means how many securities you are using for controlling the EC2 instance. So not only security group, man, we normally think security group and knuckle. No, also the IAM role. I showed you IAM role is why? To avoid the access key and secret access keys exposure. So we are using the role there. And knuckle, provides the stateless filtering at the subnet level. So knuckle when coming is the subnet level. But the question is for EC2, but we are also securing the subnet level. Why? Because from subnet to EC2 traffic is coming. So not only security group which is attached with EC2 instance, not only that one, also knuckle which is attached with subnet, that one should be also secured. And IAM role, of course, and tags can also help in organizing and securing resources by tracking ownership and purpose. So tags for purpose. What kinds of purpose? Which one is that? This is for tracking the ownership. This is also the part of securing. See here, securing. Scenario. Use cases for security groups. If you are hosting a web application on EC2 instance, you would configure a security group that allows inbound traffic on port 80 and port 443, but restricts all other traffic. That means here is the stateful security group is the stateful. You can if you put like that 80 and 443, that means HTTP and HTTPS. Without these two ports, all the ports are restricted. So this is implicitly restriction done. So use case for IAM policies when using EC2 instance to interact with AWS services, S3, DynamoDB like that. IAM policies can limit the permissions granted to the instance, ensuring that it only has the necessary access to resource. Okay guys, hot number 8. What is the difference between EBS and instance store as root device types? EBS, elastic block store, instance store. EBS, persistent storage that can be attached to EC2 instances. Data remains intact even after the instance is stopped or terminated. So if the EBS volume is not attached with EC2, like it will be terminated at the time of termination of EC2, then it will be remained. it will be remain. That means data remains. Okay. Then instance store, temporary storage directly attached to the physical host. Data is lost when the instance is stopped or terminated. So the biggest difference is instance store data is lost when instance is stopped or terminated. Very much important. Not only terminated, also for stopped. This is really significant because instance store is the temporary storage. This is the permanent, directly attached to the physical host. So physical host when it's working, so if you attach the instance store, so that one will be finished or vanished or lost when this is stopped. If this is even this stopped, of course termination should be out. But EBS volume, it can remain. I'm making red this one. Remain even stopped, of course remain even after termination also remained. Man, this is important. So when you're creating the EC2 instance, there is the one option. EBS volume will be terminated. Also the termination policy of EC2, if you yes or not. So normally we are doing the yes, but in the real time when you are in the project, please keep in your mind, you have to ask your manager that what should be the policy of EBS volume. It should be terminated with EC2 instance or not. Very, very important. It's small thing looks like, but in the real project, if you don't ask to your manager and if you keep the tick EC2 instance when terminated, EBS volume will be terminated also. And if this is terminated accidentally, and all the information from EBS volumes will be lost, maybe you can lose your job also, honestly, maybe. So please make sure that this small thing maybe it becomes the big thing in your career also. Use case. Okay, EBS, if you need to retain data, already I said, right, retain data after an instance is terminated or stopped, EBS is useful. For temporary, when instance is store coming, temporary storage does not need for persist after instance stopped, such as cache data or temporary files. So cache data, actually cache the data for instance store. The question, the guys who are trying to get the certification for AWS DevOps engineering or AWS solution architect, this is the one of the question, that the cache data with cache data one EC2 instance is launched, should be launched. So what kinds of storage should be EBS or instance store? So cache data, keep in mind cache data for instance store. Cache data, that means temporary something, right? No need to be stored. Okay, then what is the T2 and or T3 unlimited feature? T2 and T3 instances support the unlimited mode feature, which allows the instance to burst beyond its baseline CPU performance for as long as needed. This mode is helpful when your application occasionally requires more CPU than the baseline can provide. That means burst. When T family is coming, just burst, thing like that. Use case of T2 or T3 unlimited. Suppose you are running a small application that occasionally experiences spikes in traffic. Occasionally, man. Okay, not every time. Marketing campaign or product launch. Basically, for I think Diwali in the India or the Black Friday in the USA, Christmas in the USA and Europe especially, T2 or T3, this family is coming. T2.medium, vastly used. T3.medium, vastly used. With T2 or T3 unlimited, your instance can burst beyond its baseline performance, handling the additional load without requiring you to manually scale up. Okay guys, so rest of things I will cover later. Okay, so yes, so this is the part 7 and part 8 will be the rest of things. Stay safe. Thank you very much. See you again.